So now we're going to solve this system, and we're going to first put it in an augmented matrix. So I'm going to write down the coefficients. And augment that with the right side of the equation symbols. So first thing you want to do is get a 1 in this first entry. So how I'm going to do that is I'm going to switch the first two rows. So I'm going to replace row 1 with row 2 and vice versa. And again, this is not the only way to do this, but this is how I'm going to do it. And I'm going to divide this first row by 2. So I'm going to say replace row 1 with 1/2 row 1. And again, I'm only changing row 1, so I'm just going to write down the other rows. So now I want to get rid of the 4 in the third row. So I have to use the first row to eliminate that 4 in the third row. So I'm going to say replace row 3, so I want to change row 3 with row 3 minus 4 times row 1. So I'm going to multiply row 1 by negative 4, and add it to row 3. I'm not changing row 1, and I'm not changing row 2. So we got to multiply row 1 by negative 4, and I think it's a good idea to make notes. So let's multiply this row by negative 4. So it's going to be negative 4 times 1, and then negative 4 times negative 3/2. So that's 2 negatives, so it's going to be positive. 4 divided by 2 is 2 times 3, so it's going to be 6. And then negative 4 times 1, and then negative 4 times 1/2, that's going to be negative 2. So when I add these, negative 4 plus 4 is 0. I'll just leave it in red. 6 plus negative 8 is negative 2. Negative 4 and 12, that's going to be positive 8. Negative 2 plus 1 is negative 1. So our first column is finished. So we have this 1, 0, 0 in the first column. That means we can move on to the second column. In the second column, you want to get a 1 in the second position, and that's what we have. And we're going to use that 1 to eliminate the second variable in the first row and the second variable in the third row. We're going to make those zeros. So I'm going to do this all in one step here. So let's replace row 1 with row 1 plus 3/2 row 2. So if I turn this 1 into a positive 3/2, then I'm going to add it to the negative 3/2, and I'll get 0. And then for row 3, we need to add 2 times row 2. So I'm going to multiply this 1 by 2, and then added to the negative 2 will give me a 0 there. So I'm not changing the second row, but I am going to change the first and the third. So let's make some notes here. I'll do the first row first. If I multiply row 2 by 3/2, so this will be 3/2, and 3/2 times -4, what's that going to be? So it looks like it's going to be -6, right? And then 3/2 times 8, that's going to be 12. So I'm going to, and the first one's going to be 0, right? Because we multiply 0 times 3/2. So 1 plus 0 is 1. -3/2 plus 3/2 is 0. 1 plus -6 is going to be -5. And then 1/2 plus 12. So 12 is 24/2, right? 24 plus 1 is 25, so it's going to be 25/2. And for the third row, I'm going to multiply row 2 by 2, so this is going to be a 2. It's going to be -8. It's going to be 16. All right, and then, of course, 0. So 0 plus 0 is 0. That's what I wanted. 2 plus -2 is 0. I wanted that. -8 plus 8, that's also a 0. That wasn't in the plan, but we just have to take what we get. And 16 plus -1 is 15. So we have an interesting result here. We've got all zeros on the left and something non-zero on the right. So this equation, this row represents an equation. So the equation says 0x1 plus 0x2 plus 0x3 equals 15. And that obviously can't happen, right? So the whole left side is 0, and 0 cannot be equal to 15. So this is an example where you get a system with no solution. So that happens when you're solving an augmented system and everything on the left in a row is a 0 and the entry to the right is non-zero. If this was a 0, then there's no conflict, right? If this 15 was 0, then we don't get a no solution. But if it's non-zero and everything on the left is 0, that's no solution.